Hello folks, so I'm back for part 2 of this lesson. So you might have been watching part 1 and noticed the last 5 minutes is like a green screen. I lost the last 5 minutes of part 1 because my power flashed on and off, so my internet went out and I guess it stopped recording. So I apologize, it probably cut off pretty abruptly after my discussion of variance. Remember, variance is one of the measures of dispersion that I want you to know exists, but I won't be asking you to calculate. Then the last part before we do the practice is on how to report descriptive statistics. So descriptive statistics are our measures of central tendency that we did last week in chapter 2, and now our measures of dispersion that we've done this week in chapter 3. So anytime you have an interval level variable, aka a quantitative variable, there's 4 pieces of information that you always report. So if on the classwork or when on the classwork and homeworks, I ask you to report all appropriate descriptive statistics for an interval level variable, you will always, always, always report these 4. And remember, I've mentioned before that statistics is one of those funky things that has its own precise and very nitpicky kind of language that you're supposed to be using. And that applies here for reporting descriptive statistics. So always, always, always use the same exact format for the sentences as I have as an example here. And we'll, of course, have more practice on this with the practice problem at the end of this lesson and then in the classwork as well. So there's 4 statistics that you're reporting for an interval level variable. The n, how many values or cases there are, the min and the max. The min is the lowest value, the max is the highest value, as well as the range if you want to. Range is optional, right? If the reader has the min and the max, it's easy for them to calculate the range on their own. Then you're also reporting the average, either the mean or the median. If you have no outliers, then you report the mean. If you have outliers, then you report the median, as well as then the last one on dispersion is standard deviation. So I have kind of color coded for you here using the example of Caitlin's Place that we had in the beginning. The 5 dishes available at Caitlin's Place have a range of $15 with a maximum value of $20 and a minimum value of $5. The mean price of dishes is $11 and the standard deviation is $5. So this is one of those things that the mean and the standard deviation always, always, always go together in the same sentence. So this is just something the statistics gods have decided that you always use. This first sentence has the n, the min, and the max. Second sentence has the mean and the standard deviation, or the median and the standard deviation together in the same sentence. Okay, what if though you're reporting the appropriate descriptive statistics for a categorical variable, a nominal or ordinal level variable? This is a little easier that you only have 2 statistics to report, the n and the mode. So again, you report the number of cases as well as the most common category, which is the mode. So for let's say we had a survey of soda drinkers and asked them what their favorite soda was, we would be able to say in a survey of 50 regular soda drinkers, that's our N, Pepsi was the modal category. So always, always, always use that same exact sentence format. Okay, so that's what had been cut off of part 1, the part about reporting appropriate descriptive statistics. Let me shut my video off so that my face is not getting in the way of this practice. Okay, actually, one other thing while I'm thinking of it that I wanted to show you why I put the video on for this one is I mentioned in the first one, let me do this without showing you text and everything. I mentioned in the first video about when you're calculating standard deviation and you need to do the square root and you're using just the calculator in your phone, that here we don't see a square root button, right? But if we turn our phone like this, magically all of these other buttons now appear. So the one that you use for square root is this one right here that has the square root with the 2. So I hope that you can see that all right. But if you weren't sure what I was talking about, the way on your cell phone to get all of those other options on your calculator, including most importantly square root, is to just turn it into portrait view. Okay, without further ado then, let's do one of these practices together. So this one is saying compute by hand the range and the standard deviation for the following set of values. And for extra practice, I give you at the end of this one too, the all appropriate measures of, all appropriate descriptive statistics. But for this, it's the range and the standard deviation is what we're really practicing, right? So let's do standard deviation first. So this is given this set of 7 different values. Remember when we are, sorry, my screen's frozen here. Okay, so first step for setting up standard deviation is you are writing out 4 different columns, right? First column is X, second column is X bar, that'll be your mean. Third column is X minus X bar. Fourth column is X minus X bar squared. So step number 1 is to list all of your X's, all of your values. That's just the numbers that are given to you as part of the problem. So step 1 is you're listing all of the values. Step 2 is you're calculating the mean. So the mean here, if we add 10 plus 15 plus 25 plus 40 plus 80 plus 100 plus 130 and divide by the number of values there are, divide by 7, that gives us a mean of 57.14. You'll see in classworks and homeworks, I will usually ask you to round to 2 decimal places. This is important because for something like this that has multiple steps, if you round to 1 decimal place or 3 decimal places and I round to 2, by the time we go through all of the steps to get to our final answer, they're going to be substantively different. So it's important for us to all round to the same number of decimal places, which 2 is what I go with as the standard. So here, if we round to 2 decimal places, the mean is 57.14. If it's helpful for you, write 57.14 down in each of these spots. Otherwise, you can just draw an arrow knowing to tell yourself that this is 57.14 all the way down in column 2. All right, so column 1 is just all of the values given to you. Column 2 is the mean. Column 3 is our X minus X bar. So our value in column 1 minus our value in column 2. So 10 minus 57.14 is negative 47.14. Remember here in column 3 that the negatives matter. You want to keep those negatives in there. 15 minus 57.14, negative 42.14. 25 minus 57.14, negative 32.14, ... right? All the way down. Do this for all of these, subtract 57.14 from all of the values. Remember, a helpful check on your arithmetic here is that everything in column 3 should add up to 0 or close to 0 if you've been rounding. So because we've rounded here, we know that it's okay to have this as 0.02. If this came out as something like, 4.5, then that's going to be big enough that we know that that's not just an issue that's due to rounding, but that column 3 should always come close to 0. Column 4 then is our X minus X bar, that's everything in this column 3, squared. So negative 47.14 times negative 47.14 is 2222.18. Same thing for all of these other values. Square each of these values. Remember that a negative times a negative is always a positive, so that's going to end up in all positives for column 4. So we're multiplying each value by itself in column 3 to get the values in column 4. Then step 5 is to add up everything in column 4. So we're adding 2222.18, 17 plus 1775.78 plus 1032.98, ... right? Add up all of these values in column 4. Be careful about the fat finger calculator errors, and to get then our final value here. Remember then that that is the numerator. That's the value that goes on top of the formula. Then we have n minus 1 on the bottom. The n is the number of values in the problem, in the data set. Here we have 1, 2, 3, 4, 5, 6, 7 values. So our n is 7. So 7 minus 1 goes on the bottom. Go through and do the math for that. gets then a 6 on the bottom, divide 12,992.86 divided by 6 to get 2,165.48. Take the square root of that value. Remember, turn your calculator into landscape view to get that square root button, and you should come then to a final standard deviation of 46.53. If you also wanted to calculate the range for this, we would simply just take the range as the highest value minus the lowest value. So 130 minus 10 would give us a range of 120. Remember, when we're reporting all of the appropriate descriptive statistics, you have 4 things that you have to report. Well, 5 things if you count the min and max as 2 things. You always report the n, the minimum value and the maximum value, and then in sentence 2 is the mean and standard deviation together in the same sentence. So here we write among the 7 values, the minimum value is 10, and the maximum value is 130. If you wanted to add at the end of the sentence, comma, with a range of 120, you could do that. Then the second sentence is the mean is 57.14. The good thing with doing standard deviation is that we calculate the mean as part of doing the problem. The mean is 57.14 with a standard deviation of 46.53. So hopefully doing this as an extra practice, you're starting to feel a little more confident about calculating standard deviation on your own. If not, go back and watch both of these parts in the lesson again. And then after you do the classwork, I think you'll be feeling a good bit better. Good news is that Excel can do all of this math with a click of a button for us. So I want you to open chapter 3, data set 3, and make sure you have your lesson handout, your lesson outline handy, because that has all of the step-by-step instructions for calculating things. So let me jump out of this and go to instead let me make the view zoom a little bigger here. Go to chapter 3, data set 3. Let's try this. That's good. Actually, sorry, give me just a sec so we can see this best. So you should have chapter 3, data set 3 open and the lesson outline handy. The last page tells you how to do the analysis in Excel. The first one says for calculating minimum and maximum values and range. So sometimes it's helpful for you to set up a little table on the side with all of the different statistics you're going to be calculating, so it's easier to keep track of things. It has a data set of 20 different people and their heights and weights, so height in inches. And so first, to calculate the minimum value, let's say we're calculating the minimum value for height, you would put the cursor first in the box where you want the answer to go, then type into the formula bar equals, remember always write the equals, and then you're giving the range for what data you want it to do. So if we're doing for height, this would be from cell A2 through to A21. So we write equals min. Our first number is A2. Remember, then the colon tells Excel to do the range between the 2 values. So A2 colon A21, press enter, and that gives us a minimum value of 44, right? So that that's easier than scanning through here, putting them in order. Then we can calculate the maximum value by doing exactly the same thing, except we're writing max instead of min. So you write equals max A2 colon A21. Then to do the range, you have a couple of options for this one. You can do what is the cell here, so like E6 minus E4, or just type in the value, so like 87 minus 4, and again, the equals, always remember the equals sign first, will automatically calculate the range for you. And then to do the standard deviation, this is where it gets really fun because you've just gone through all of the hassle and pain in the ass of doing all of the steps by hand. So you will now really appreciate how easy this is to do in SPSS. All you need to do is type equals STDEV for standard deviation. And you'll see there's lots of different options here. We want to use the one with .s at the end. Beyond the scope of this class to explain all of the different ways we can be calculating standard deviation, we're using the STDEV .s. And then again, giving the range we want it to calculate for. Here, if we're doing it for height, we would say A2 to A21. For a standard deviation of 11.44 if we're rounding. So we can interpret this as saying, on average, each person's height is 11.44 inches away from the mean. So the standard deviation, remember, is a representation of how far, on average, is each value from the mean. And so we can do then all of the same things for weight. If we recreate our table here for weight, I think the min, max, and range is pretty straightforward, so I won't talk through doing that again. But let's do the standard deviation now for weight. So we're doing the STDEV.S for now B2 to B21. And this gives us a standard deviation of 15.65. If we're comparing the standard deviations for height and weight, we see the standard deviation for weight is greater than it is for height. What this tells us, remember, is then that the values for weight are more spread out or are more dispersed than the values for height. So if you had a classwork problem or a homework problem that was saying something like which variable has greater variability or is more spread out, you would compare the standard deviations for both variables. Here, if I asked you which variable has greater variability, height or weight, you would explain that weight has greater variability because weight has a standard deviation of 15.65 compared to the standard deviation for height of 11.44. A higher standard deviation means greater variability. Things are more spread out. Okay, folks, that is it for this part on Chapter 3 and variability. Make sure next you give the classwork a try, and I'll have posted by Wednesday at the very latest the answers on the classwork.